All right, you guys. The next type of problem is actually something that is going to be obviously a building block for later on, and we can actually consider it right now. Keep in mind, most often than not, right, we have not been actually able to find the angle. Usually, we're just talking about the sine of theta, and it's equal to some ratio for us, and we were okay with it. We just use it, we work with it, and whatnot. This is probably one of the first times we've actually been considering, right, what angle, and we're going to just consider our first rotation, because remember, because of coterminality, there's actually an infinite number of solutions. But just in our first rotation, right, where is the sine of theta equal to the square root of 3 over 2? Right, where's the cosine of theta equal to minus the square root of 2 over 2? And then where's the tangent of theta equal to the square root of 3 over 3? So where in our first rotation do we have that? And it turns out that there's a lot of previous knowledge that comes into play combined with what we've currently learned. So here's what you got to be thinking to find the angle in the first rotation. The first thing I'm going to consider is that this is positive. So we have to kind of think, go back to way back when, where is sine positive, right? Well, it's basically positive wherever y is positive. And of course that happens in quad 1 and that happens in quad 2. So our angle values are basically, right, the solutions to this equation, if you would, are going to be, there's going to be a quad 1 answer and there's going to be a quad 2 answer, right? So that is what I can do with the positiveness or negativeness of this. So what's next? Well, again, I know it's pretty short. You guys are still getting used to this, but if you look at the ratios, there's a square root of 3 over 2. That square root of 3 is kind of a dead giveaway that we are probably talking more than likely of a 30, 60, 90 right triangle. So we got 1, square roots of 3, and 2. And so looking at this picture and working backwards, right, our ratio sine, right, this is my opposite over my hypotenuse. So we're basically looking, right, what's, square root of 3 is opposite of what angle? Well, it's opposite of 60 degrees. So one of our solutions here is 60. But, right, we are expecting another one in quad 2. So we have 60 degrees here, but following our reference angle stuff we have, there's got to be a 60-degree reference over on that side. Of course, what angle has that 60-degree reference? Well, that would be 120 degrees. So my solutions here, there's two angles, 60 degrees and 120 degrees, that basically have the solution, the exact solution of the square root of 3 over 2. So pretty, it doesn't look that involved, but look how much of the trig we've learned in the past that I'm putting into play, right? I think in chapter 1 we talked about where am I positive and negative. I use that, right? Now what I'm using is my the current stuff about my right triangles and expected ratios. And then once I have that, my opposite, adjacent, and hypotenuse, who's who here. And then we use the idea of the reference to find that other angle. The quad 1 one was pretty clear, but the quad 2 one we kind of had to work for. All right, and so that's how we're putting a lot of ideas together. So something so simple, putting so much of it. And I think I have in the past told you guys how math builds on itself, and this is a problem showing you exactly that. Past ideas playing a role helping us here. So the next one, right? We got the cosine of theta equals the square root of 2 over 2, and most importantly, it's negative. So the first thing we have to figure out is where is cosine negative? Well, cosine's usually negative where x is negative, right? Using our old XYR definitions back in chapter 1. Well, where's x negative? Where's cosine negative? Quad 2 and quad 3. So in my first rotation, I'm expecting, all right, two answers, a quad 2 answer and a quad 3 answer. Okay, so what's next? Well, again, take a look at the ratio, right? Whereas the first one had a square root of 3, this one has a square root of 2. So what kind of triangle, right, in 2 and 3 has that situation going on? Well, that's a 45-degree reference. So in quad 2, we have a 45-degree reference, right? So, and in quad 3, we have a 45-degree reference, right? And again, that would be -1, 1, -1, square roots of 2, square roots of 2. And in that case, right, cosine would be my it's going to be negative because x is negative, and then it's going to be a 1 over the square root of 2, negative 1 over the square root of 2, which if I rationalize gives us the answer that we're looking for. So now, right, it's not enough, we know there's a 45-degree reference in these quadrants. What are the actual angles? So if I rotate it here, let me use another color. If I rotate it till I have a 45-degree reference there, right, I believe that's going to be 135 degrees from previous work that we've done. If I continue that rotation, right, if I would go all the way down to here where I have a 45-degree reference, we went from 180 plus 45, and I believe that's 225 degrees. So there's how I use previous knowledge. What sign am I at? Which quadrant am I at? Right? Which ratio am I dealing with? Which gives me a clue as to which reference angle I'm dealing with. Draw your reference angle, right? And then you can pretty much from there establish what angles we're talking about within the first rotation. So 135 and 225. A lot to it, all right? So make sure the more you commit some of these ideas to memory, the easier it's going to go. Of course, you can always draw the pictures like I am to make sense of it. Last but not least, tangent of theta equals the square root of 3 over 3. And so now what we're dealing with, right, is it's positive. So where is tangent positive? Well, we know for sure it's positive in quad 1 because everybody's positive, right? Y over x, everybody's positive. It's also positive in quad 3 because I would technically have a negative y over a negative x in that quadrant, and it's also positive. So we're expecting an answer in quad 1 and quad 3 here. So what is it? What angle is it? So again, there's that square root of 3. So I know, right, I have, right, in terms of some stuff here, right, I have to have a 30, 60, 90 right triangle. And so I believe if we go here and here, right, there's 30 and 60, right, this would be 1 square root of 3 and 2. And the tangent, right, is if we looked at it from here, it's the opposite over the adjacent. And if I rationalize my denominator, I get the exact ratio that I'm looking for. So we basically have a 30-degree reference. And since we were expecting a quad 1 answer, I actually know what one of my solutions is, 30 degrees. But we know there's an answer in quad 2. So we also have, right, so let me rotate this through. So we also have another answer, right here with a 30-degree reference. All right, and that would have been, again, if I labeled it, negative square root of 3, negative 1, and 2. And so what would that ratio be? Well, again, we went 180 and 30 more, puts us at 210 degrees. So there's how I can solve, find which angle value. And again, right now we can only do this with our special ones. So our quadrantals, right, 0, 90, 180, and 270. And now anything that has a reference angle of 30, 45, and 60. I can draw the reference angle. I can draw the representative right triangle. I can draw that reference angle, and then use my coterminality and whatnot to find out exactly what angles that we're at. We're going to be doing this a lot. All right. I think this is the first chapter where we actually get a feel for it. So work at it. Draw your pictures. Make sense of it. And you'll notice how my memorization helped me. Right. So square roots of 3's usually involve 30, 60, 90s. Square root of 2, you're talking about some sort of a 45-degree reference. So there's kind of a little bit of inside information to help you draw your pictures. And then we invoked, right, where am I positive and negative back in chapter 1. So all of it, this is a great problem where a lot of ideas come together. All right, that officially wraps up section 2.2 and our current trigonometry week. All right, if you need help, please ask. Jump on Canvas and ask your questions. You can, if there's something there that makes sense in the videos, or if you found an error, let me know. Request a virtual office hour. Go to the Math Solution. Lots of places to seek out help. Otherwise, you guys just keep on grounding and pounding, and I'll watch your action and your submissions on Canvas. Thank you for your time and your effort.